Hello! In this video, we're going to figure out the center of mass of the shaded region. Now, let's assume that our shaded region has uniform density ρ. And let's be clear, the shaded region is really a circle of radius r, with a smaller circle of half the radius cut out of it. And this smaller circle extends from the center of the larger circle to the radius of the larger circle. Okay, so that's really what our shaded region is. And let's call the smaller circle region 1. And let's call our shaded region region 2. So together, region 1 and region 2 make up the larger circle. Okay, so how do you suppose we figure out the center of mass of the shaded region? Well, let's start out by finding the y center of mass of the shaded region. It turns out that the y center of mass of the shaded region is just 0. In other words, it turns out that the y center of mass of region 2 is 0. And the reason why is because of symmetry, right? We know that the shaded region is symmetrical about the x-axis. Okay, so then how do we figure out the x center of mass of the shaded region? Well, before we do that, let's think about where we expect the x center of mass to be. Well, first of all, I think it's pretty clear that most of the mass of the shaded region is to the right of the y-axis. So we expect the x center of mass of the shaded region to be to the right of the y-axis. And we probably expect the center mass to be somewhere about right there, right? We know that the center mass is going to be on the x-axis because the y center of mass is 0, but we also expect the center mass to be to the right of the y-axis, right? And so our goal is to figure out the x-coordinate of the center of mass. So how do we do that? Well, it turns out we can use a property of centers of masses, which goes like this. If we take the mass of region 1, multiply it by its center of mass, then add that to the mass of region 2, multiply it by its center of mass. If we take this and divide it by the total mass of region 1 and region 2, then it turns out that this is equal to the center of mass of region 1 and region 2 combined. So really, what we're going to do is we are going to take this equation and solve for x2 center mass, right? We're going to solve for the center mass of region 2, the shaded region. And to do that, our problem asks us to figure out what it is in terms of r. So we should probably re-express m1, m2, x1 COM, and x1, 2 COM in a different way. But wait a minute, what do we mean by m1, right? Region 1 is really a cutout circle. So currently, region 1 is just empty space. So the technique we're going to use is we're going to imagine filling up region 1 completely so that region 1 has the same uniform density as region 2. Really, we're going to treat region 1 and region 2 as though they have the same uniform density ρ. Let's start by re-expressing the masses in a different way. Now, first of all, we know that mass is related to density. And in this case, the density we're dealing with is an area density because our regions are areas. So by definition, we know that density is equal to mass divided by area. In other words, mass is equal to density times area. So really, we have that the mass of region 1 is equal to the density times the area of region 1. And similarly, the mass of region 2 is equal to the density times the area of region 2. Okay, so next, let's figure out the x center mass of region 1. Region 1 has a uniform density, so the center mass of region 1 is at the center of the circle. Now, we know that the radius of this smaller circle is half the radius of the larger circle, so really, this length is r over 2, which means that the x-coordinate of this point is negative r over 2. So the x-center mass of region 1 is negative r over 2. And lastly, what about the x-center mass of region 1 and region 2 combined? Well, remember, after filling up region 1 completely with the same uniform density as region 2, we now have that region 1 and region 2 have the same uniform density throughout. So that means the center mass of region 1 and region 2 combined is at the center of the larger circle, which is at the origin. So really, the x-center mass of the larger circle is 0. So now that we've re-expressed these four things in a different way, let's go ahead and plug them in to our equation. Okay, so we don't need this stuff anymore. Okay, so the next thing to notice is that the density is actually going to cancel out. And to see why, if you were to take the numerator and factor out rho, and you take the denominator and you also factor out rho, then the rho's will algebraically cancel out. So I'm just going to cancel out the rho's. And before going any further, let's just simplify this up a little bit. For the first term, we just have negative 1/2 a1r. For the second term, we have plus a2 x2 com. And in the denominator, we just have a1 plus a2. So now, let's re-express the area of region 1 and area of region 2 in a different way. Starting with the area of region 1. Now, region 1 is a circle, so its area is really just pi times its radius squared. And the radius of region 1 is just r over 2. So the area of region 1 is pi times r over 2 squared. And of course, r over 2 squared is just r squared over 4. And this is equivalent to 1/4 pi r squared. So this is the area of region 1. Now let's go to the area of region 2. So to get the area of region 2, all we gotta do is take the area of the larger circle and subtract it by the area of the smaller circle. In other words, we're taking the area of region 1 and region 2 combined and subtracting it by the area of region 1. Now, the area of region 1 and region 2 combined is really just the area of the larger circle, which we know is just pi r squared. And we take that and subtract it by the area of region 1, which we already found to be 1/4 pi r squared. If we subtract these, we're really just combining like terms, so we get 3/4 pi r squared. So now we have the area of region 2. So now let's go back to our equation and plug these two things in. Now the area of region 1 plus the area of region 2 is really just 1/4 pi r squared plus 3/4 pi r squared, which we know is going to be pi r squared. And so now we don't need this stuff anymore. Now, notice pi r squared is going to cancel out with some stuff up here. Notice we have that pi r squared will cancel out with this pi r squared, and pi r squared will cancel out with this pi r squared. So now what we have here is negative 1/2 times 1/4 times r. That gives us negative 1/8 r plus 3/4 x2 com. And let's get rid of the fractions, right? We're going to multiply 8 on both sides. So on the right-hand side, we get 0. On the left-hand side, we distribute the 8 across. And if we do that, we know that 8 times negative 1/8 r is just negative r. And we get plus 8 times 3/4, which is just 6 x2 com. Right? And adding r to the other side, we get, and then next, all we do is divide 6 to the other side. So we get x2 com is equal to 1/6 r. So now we have the x center of mass of our shaded region and the y center of mass of our shaded region. And so writing this as an ordered pair, we have the center mass of our shaded region is 1/6 r, 0. And so this is the center mass of the shaded region. And yeah, that's pretty much the idea of how you could solve a problem like this. So yeah, that's pretty much it for this video.